Hello friends, in my Hadoop video series, today I will be talking about some internal elements that is present within Hadoop. Well, we already know that there is a term called file system, whether it's a Windows-based operating system or whether it's a Linux-based operating system, each OS has to maintain a file system which deals with handling files, copying files, moving files from one place to another. So all kind of file management will be ensured by file system. Like we are familiar with NTFS, FAT32, ext2, ext3 for Linux-based OS. So these file system will maintain or will keep the information about the files that we store within our OS. Similarly, as we move ahead, we know that the file system can be based on a single computer or it can be a network-based operating system. Imagine there is a network where series of computers are connected among each others and we need to maintain the detail of this entire network. So a file system like NTFS will ensure the detailed information of the system that is present in the network. Keeping this in view, we get into the world of Hadoop. So what Hadoop is going to do? Hadoop is going to implement something called distributed file system. So the previous thing which we saw was a network. So that means in order to implement Hadoop, the network environment is very much required. So imagine this network is there where different systems are interconnected among each other, and we want to implement Hadoop over here. What it would be doing is that it will store our data within these systems that are present in the network, and that gives birth to something called distributed file system. And that's what we will see in the upcoming slides. So that means Hadoop gives us or Hadoop gives birth to something called Hadoop distributed file system. That means it's also a file system that deals with the files. That means we will be storing our information in the files and within the operating system, and this operating system will be taken care by Hdfs so that the proper file management is need to be ensured. That is what our Hdfs would be taking care of. Okay, so we move to the next slide, and here we see that the previous network is still existing, and this network is now within the clusters of Hadoop, and within this Hadoop clusters our data are going to be distributed, and that gives birth to a two new term that is called name node and data node. So in every network there will be one computer which will be considered as a master, and that master will be known as name node, and that master will have a proper information about the systems that are present within the network, and those systems which are the part of the network will be considered as the data node. So that means in every network there will be at least one name node, and n minus 1 systems are going to be considered as a data node. So what is the relevance of this thing that we'll get into means we will come to know about that. So HDFS is a distributed file system which deploys on the low-cost commodity hardware. That means the systems that will maintain in the network are not going to be very costly. They are going to be low cost. What Hadoop distributed file system has to implement is a block structure. So there will be, that means suppose we have a file and the capacity of the file is pretty large, the HDFS has to ensure that the file should be broken into different blocks, and that blocks will surely have some specific size, and that block has to be stored within the system in this particular network, and that what gives birth to something called name node, which will be the master node, and the other nodes are going to be data node that are slaves node. That means within the slave node data node we will be storing our files, and this whole system has to be implemented with the help of Java. Okay, so do remember HDFS consists of two terms. That one is your master node or the name node and the slave or the data node. So the diagram basically explains that thing only. So these are the data node and this is your name node. So now what actually happens? Well, suppose you are sitting in one of the client system, okay, where Hadoop is working, and you want to save a particular file. So this is a command which we will see. This is a command for file handling in Hadoop environment. So you have a file, and let's give the example of the file name as big file.csv, and that file is pretty big in size. So what we have to do is that we have to break that particular file into different blocks. So this is the first block, second block, third block, and the last block has got the size of 100 MB. So this block you need to store within this data node. So how we will be storing this block is what we will be seeing it. So the first thing the client will be doing is that it will consult with the name node, and the name node, while consulting, it will pass the metadata. That means it will pass the detail about all these blocks, the files that it wants to save within the Hdfs environment. All the information will be sent to the name node. As the information goes to the name node, it's similar like you want to create a file and the name of the file is myfile.txt. You have referred this information to the name node, and these are the data node that is present in the given network. So what it will be doing is that it will refer with a concept called fs image, file system image. We will see that. So your name node is going to have the entire detail of the file system image. That means it has got a blueprint of all the system that is present in the network. It has got all the information about that, and it will be consulting this fs image. And once the information comes and been compared with this fs image, like whether this particular file already present or not in the system, in the network, and if so, then the information has to be forwarded back to the Hadoop client. Otherwise, you need to present a confirmation message that yes, we can save it within this given environment. So a message of acknowledgement will be forwarded to the client. Once receiving that acknowledgement, what the Hadoop client will be receiving is that at least it will receive a list of IP address of the data node where this particular blocks are going to be stored one after the other. So once the Hadoop client receives a list of IP address, that means the name node need to know all the data information which is present in the network. That's the reason it can forward the IP address to the Hadoop client. And on receiving that information, what the Hadoop client is going to do is that it will create a data output stream. So fs stream will be created over here, and this particular stream will be holding the data block which will be forwarded within this particular data node. So the first thing, on receiving the success message, it will create the output stream, and it will be generating the block, the first block of 128 MB. It's a default block size of 128 MB will be generated. So this particular block will be forwarded to the data node, but in consultation with the name node. So the Hadoop client will pass information that I have got one block of information of 128 MB. I need to store within the network that your name node provides. So a request goes to the name node, and then the name node will let you know that you can save this particular block in data node 3. So this information has been retrieved by the name node on verification of this particular entire data node that is present in the network, and on availability of a data node, the information will be forwarded back to the client, and then eventually the client will be able to save this particular block into the respective data node 3. So after the successful storage of the data node first block in the data node 3, now what happens? The data node 3 has got a very big role to play now. There is a concept of replication. Since we know that the Hdfs will be dealing with the low commodity hardware, that means the cost of the client computer are pretty less, so there can be a failure. So you cannot just store a particular block in one data network. So in that case, if there is a loss of, or if the system goes down, then in that case the network or the data node will be not available. And that's the reason why the respective data node which is holding the first block will also ensure the replication, and generally the replication factor is 3. So the data node 1 will store the information of the same replication within the another data node, and then eventually a connectivity in the form of a linked list will be formed, and the next data node 2 will be storing the data node 3, and that's how entire replication will be taking place one after the other. And obviously the information will also be stored in the name node. Eventually the first block gets stored, and then after the allocation is over, then comes the next block, because the file size is pretty big, so we have to store multiple blocks of data. So the next block will come in picture, which again will be send a request that I want to store the second block of information, and as usual the name node will forward the information that you can store this particular block in data node 1, and eventually the client will be storing the particular block in data node 1. So a very cyclic order, the whole transaction is going on, and finally what happens is that all the blocks have been stored and there is no block left, and then comes the information from the client that I have no further blocks to store, and finally the whole transaction gets over. So during this whole transaction, these are the following terms that we have come across, and we saw that how name node plays a very important role. So we can say that it's a master daemon. So daemon is a service that we call in Windows operating system that runs in background that maintains and manages the data node, which are basically my slave node. So what are the functionality the name node is going to do? It record the metadata of all the files stored in the cluster, the location of the block stored. Obviously, a client, when it's storing a particular file with the data node, the name node should know where the blocks are present, the size of the file. Obviously, we saw that each block initially has got 128 MB, but the last block will be less than 128 MB. The permission which we have seen in the Linux environment, the executive permission, the write permission, the read permission that has been acknowledged to the different user or the others of the group. Okay, the hierarchies, which file or which particular block followed by which block, so the chain of blocks has to be maintained. And we also saw there are basically two type of file associated with the metadata. One is called file system image, which is present with the name node that has a complete state of the file system namespace that start with the name node. Now what happens, you cannot ensure that the name node should be like in a network environment. There are so many computers are present, so any point of time one of the computer can get down. So this information of unavailability of the system need to be informed to my name node. And just imagine at that point of time, when name node is performing any kind of operation, so there will be a disruption. That's the reason at the background there is one more file that comes in picture, is called edit log. It contains all the recent modification made in the file system with respect to the most recent file system image. So whenever any network goes down or any particular terminal in the network goes down, the immediate registration of that information will be done in the edit log. And after some span of time, this information will be triggered back to the file system image. So these two files will work in tandem. Okay. So it records every changes that takes place in the file system metadata. For example, if a file is deleted from the Hdfs, the name node will immediately record this in the edit log as well. Okay. It regularly receives a heartbeat and a block report from all the data node in the cluster to ensure that the data node are alive, because we know that it is working on a low commodity hardware. So the data node always at some interval of time has to inform back to the name node that it's present in the given network, and that's how the name node will come to know that which are the terminal that is present in the given network, so that when the file will be saved by the client, it can save it in a specific terminal. And the name node also responds to take care about the replication factor, which I said the by default replication is of size 3. In case the data node fails, the name node chooses a new data node for new replication. Okay, so entire communication traffic of the data node has to be maintained with the help of name node. So the name node, the data node, the file system image, the Hdfs, they all are working in a sequential manner, so that we can split the data or split the file into different blocks, and then sequentially we can save them in the cluster that is present or that works on the Hadoop environment. Okay, so these basic terms, please go through it. The flow diagram showed you then how this particular files are saved within the Hdfs, and I believe this particular information will be very helpful. In my coming video, I will be working on Hdfs along with that map reduce. So please do follow this particular video once again, and just wait for my next video. Until then, have a nice time.